I'm Carl Frame. I'd like to introduce you to a course entitled Corrosion and Degradation of Materials. This is an online continuing education course from the University of Kansas, and it deals with corrosion, and you see here a really nasty bit of rust on steel. Corrosion and degradation really can be a very nasty problem, and many of us face it in industry. It costs the USA something in the order of $1 trillion in direct and indirect costs each year. So this is not a trivial problem at all. We can mitigate corrosion and degradation of materials in many applications. Generally, we cannot totally prevent it. So if you are involved in any kind of industry where corrosion and degradation of materials is an issue or a concern, this course ought to be of interest to you, and that includes, I think, most of us. So I hope you keep that in mind as you go through this. The areas covered in the course include the infrastructure. We see here the Mianus Bridge collapse in the 1980s and all kinds of corrosion problems related to infrastructure, bridges, and so forth. Maritime problems, ships. This is the Titanic. These are actually bacterial rust, iron-eating bacteria. Liberty ships that had stress corrosion cracking and welds. All kinds of problems with our piers, our offshore oil rigs. Problems in aerospace industry is a low-high airlines flight that had stress corrosion cracking, lost the whole top of the fuselage in one area. So there's a lot of corrosion problems related to the aerospace applications around rivets in particular and other areas. Also in the turbine blades and jet engines, these are areas that are covered. Automotive corrosion was a huge problem back in up until the 80s. Still a problem, but much less than it used to be. But there are a lot of areas in the automotive industry where corrosion has to be addressed. Food processing is an area that still has problems with corrosion, and of course it affects safety of food. You'll see in major restaurants and on cruise ships all stainless steel kitchens. There are problems in nuclear energy production. We'll talk about this as well as conventional energy production. This happens to be at case history at Bessie Davis power plant. It was a near catastrophe. A lot of stress corrosion cracking in the welds for the control feed-through tubes. Problems in pipelines. We have all kinds of protection for pipelines, but we still have corrosion in them and problems with them. I'd like to give you some background information on the course. It was developed by a continuing education group at the University of Kansas. The lectures have all been pre-recorded in a format very similar to what you're seeing right now, and they are in PowerPoint format, as this is. There are 17 lessons to this course, most of which have been split into sessions that are shorter. It's awfully hard to sit through a very long lesson, and there are some of these in the course. This course is actually equivalent to a full semester of college course level work. You will need a computer if you sign up for this course with speakers and a high-speed internet connection in order to have this thing flow well over the internet. The lectures are on demand 24/7 and as often as a student would desire. So they're always available. There's no set schedule. There's no classroom classes, and no set schedule for listening to lectures. And all the slides from the course will be available in PDF format for background purposes. The course text is Corrosion Science and Technology. It will be provided as part of this course in electronic format. It's a very good textbook in this area, so you'll have that provided to you. The primary course goals are to understand the science behind corrosion phenomena, to understand other forms of degradation other than corrosion. Sometimes they're in combination, of course. Study how the various classes of materials behave in adverse conditions. Learn ways that we can mitigate corrosion. As I said, we can't totally prevent it. Learn how we evaluate corrosion resistance, how we inspect and monitor corrosion, and how we can provide maintenance of materials and systems to protect against corrosion. Understand the costs of corrosion and degradation, and study corrosion and degradation in a variety of important applications listed earlier. We'll talk about them again in a minute, including a lot of case histories. So there's a lot of meat to this course. There's an awful lot we cover here. I want to go through the course lessons so you get a real feel for what is presented in this course. Lesson 1 is Introduction to Corrosion and Degradation. Lesson 2 is the nature of materials, and the sessions are choices of materials and the atom, the periodic table of elements, bonding, crystal structure, polymers, composites, imperfections, diffusion, simple phase diagrams. Continuing Lesson 2, complex phase diagrams, phase transformations, the nature of water. In Lesson 3, we'll cover electrochemical corrosion, basics of corrosion, Pourbet diagrams, application of Pourbet diagrams, kinetics of aqueous corrosion, corrosion of ferrous alloys, passivation in Lesson 4 of metal surfaces, Lesson 5, corrosion of ferrous metals and rusting, review of iron-water system, Session 3, oxidation of iron and steel, stainless steel, corrosion of stainless steel, passivity of stainless steel, applications of stainless steel. In Lesson 6, once again, we're going to look at corrosion of non-ferrous metals, introduction to aluminum alloys, precipitation strengthening of aluminum alloys, aluminum corrosion resistant basics, corrosion resistance of aluminum alloys, copper and copper, corrosion basics, brass alloys and brass corrosion resistance, bronzes and copper-nickel alloys, nickel chrome, nickel moly, and nickel super alloys, titanium alloys and corrosion, titanium application, noble metals, and refractory metals. Lesson 7 is stress corrosion cracking. Session 1, introduction to stress corrosion cracking, thermodynamics. Session 3, stress corrosion cracking kinetics and mechanisms, predictive models. Lesson 8, hydrogen embrittlement. Lesson 9, corrosion assisted fatigue failure. Lesson 10, corrosion degradation of ceramics. Lesson 11, corrosion degradation of polymers. Lesson 12, mitigation of corrosion. Session 1, introduction to mitigation of corrosion and degradation. Introduction to cathodic protection, protective coating, surface preparation, electropositive coatings, nickel and copper, electropositive coatings, deposited coating, chrome, tin and zinc, hot dip coatings, paint and decorative coatings, ceramic and glass coatings, inhibitors. In Lesson 13, measuring corrosion resistance. Lesson 14, economics of corrosion. Lesson 15, inspection, monitoring, and maintenance. Lesson 16, corrosion by application, corrosion control in aviation airframes, stress-related corrosion in airframes, gas turbine engines, corrosion control in gas turbine engines, corrosion control in automobile bodies, corrosion control in auto engines and bright trim, corrosion control in food processing. Session 8, corrosion in building construction, steel and concrete, corrosion in other building materials, marine environments, nature of seawater, corrosion control with ship's paint, corrosion of ship superstructures, engine and offshore platforms, corrosion in power generation, fossil fuel boilers and tubes, control of boiler water and fireside control, nuclear power reactors, corrosion in nuclear power reactors. Lesson 17, case histories. Session 1, auto corrosion and the Mayanas River bridge collapse, Aloha Flight 243 disaster and marine corrosion. 3, Bessie Davis nuclear power plant near disaster. 4, San Onofre nuclear power station tube failure. 5 is the Elk River chemical spill. That's a lot of stuff. It's a lot of lessons and a lot of material. But there is no set time limit and no set schedule for courses. I am the instructor in this course, Carl Frame. I'm a material science adjunct at the University of Kansas. I am the prime instructor in this course, Corrosion and Degradation of Materials, also in Materials for Nuclear Energy Applications, Corrosion and Degradation of Materials in Nuclear Energy Applications, and Fundamentals of Material Science and Engineering, besides teaching in the classroom as well at University of Kansas. This is my contact information and my email. I have 2 emails, my private email and my KU email. Here's my phone number, cell phone number, so you can get in contact with me. Please, if you have questions that you want to cover please let me know and give me a call. I can also send you copies of the detailed course outlines on your request. Thank you for your time. I know this is not the most exciting thing, but at least to give you a feel for what this new course offers to you. Thank you very much.